Hey guys, it's Mr. Avant, and I'm here today to present another installment of our distance learning in the month of May. And it's really different from being in school when we used to teach decimals. Normally when we teach decimals at school, we're in a hurry, we're in a rush. We got to get this information in you before the LEAP test, or we're going to do horrible and blah, blah, blah. There's a lot of pressure off of you, but I don't think you feel the pressure of not having the knowledge and moving on to 5th grade. So we're going to kind of move it slow with this decimal learning. I'm going to give you some basic facts, and today we're going to start off slow by just introducing it to you. Lesson 1 in Module 6, we started in Module Book, and in Module 6, we start off decimals in 4th grade by talking about the metric system, because a metric system is perfect for explaining decimals. Let me explain. So you remember you have this place value chart, and we all learned this at the beginning of school way back in August in 2019, but we didn't give you the other half of the place value chart. We gave you this side of the place value chart, and we said as we move to the left that the values get bigger, and if you move to the right the values get smaller, but we stopped at the ones place. Over here we stopped at millions. Remember we had ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. Well, actually, if you keep going this way past the ones, you're in a new neighborhood, and it's called the decimal world. And the decimal world is basically fractions. Fractions are decimals. It's just another way of representing something smaller than 1, something smaller than the ones place. Okay? And so here's your decimal point right here. And the first group to the right of the decimal point is the tenths, and we say that is 1/10. 1/10. The tenth, and then the hundredths, and then the thousandths. You need to get used to seeing these new words, tenths, hundredths, thousandths, and they keep going this way, and they keep getting smaller, 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 smaller. And we have thousands, and we have 10,000s, and 100,000s, and millions. And if you're talking about a millionth of an inch or a centimeter, then you're talking about things that you can't see unless you have a microscope. So they get tiny, 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 tiny values. But another place that we see decimals that we're all familiar with is money. I know everyone loves money, but the one thing that we don't like about money is the smaller part of money, the decimal of money. In fact, we hate it so much, even the IRS, the Internal Revenue Service, when they ask for income taxes, they want you to get rid of the decimals to make the math easier. Remember, we estimate to make things easier to add and subtract, but the only time we really talk about decimals is when you go buy something, right? Like a lot of times you go and buy something and it's $6.99. Well, that is all designed to make you buy things that or make you spend more than you actually think you're spending. You see that $6, and you think, oh, it's just $6. But look, that 99 is almost $1. And so the store is actually charging you a little bit more than you think you're actually spending. That 99 cents is really close to another whole dollar, so it's really close to 7. That's a little trick they play in retail, but that's when decimals become really important. That's when change becomes really important. So let's look at our example here. We have $1, $2, $3 bills. Well, of course, that is going to be in the ones place here. There are 3 ones, or $3 in this case. I'm going to use a dollar sign and put a 3. But then the things that are left over, or the change that remains, we have here, we have 2 quarters, 2 25-cent pieces, 2 quarters, and we have 5 pennies. So 25 cents plus 25 cents is what? It's 50 cents. So I have to use my decimal point to represent something less than a 1 or less than $1. Well, that 5, and then we have 5 pennies. Well, normally you see that as 55 cents. But what you're really saying is this is 55 pennies out of $1, or 55 out of 100 pennies, because 100 pennies makes $1. So we're really talking about a fraction. Fractions are decimals. I want you to repeat this. I want you to yell it out your front door. I want you to drive your neighbors crazy and walk around the house and go, fractions are decimals, fractions are decimals, fractions are decimals, because fractions are decimals and decimals are fractions. Even the little cartoon characters know that. Okay? So, let's represent that as a fraction or a mixed number. $3.55. You see that? And if you're really good at your cash register, if you're ever a cashier, you would know that you would get 45 cents back. If I said it's $3.55 and you give me $4, I know immediately that I have to give you 45 cents back, because 45 plus 55 equals 100, or $4. That's how you make change. You get good at that after a while. So $3.55 is 3 55 or if we look at it as a decimal in our place value chart, 55 So look at the fraction here. 5/10 and 5/100, or we say 55 hundredths. 55 hundredths. Okay? Well, that is just a quick introduction to decimals. We want to get used to saying these words and seeing these words, but today in our lesson in the problem set, we're simply going to start with this one right here, the tenths. And we're going to get used to seeing this on a number line, and we're going to get used to seeing the fraction and the decimal go together so that you understand in your mind that they're the same thing. So let's move on to the problem set. Today I'm going to use the overhead camera, and I'm going to work on the problem set on paper instead of up here on the board. And I'm going to work with you to do your problem set that I'm going to send to you as an assignment. So let's move on to that. Okay, here we are back on the overhead. I know you guys missed it. I use this quite a bit. When we first started doing our distance learning, those of you who missed all the videos I made, when you go to YouTube after you see this video, you can go to my YouTube channel and you can see them, or you can go back to the old Google Classrooms to see some of the fraction work that we did. It might really help you, and I'm hoping some of you take up the opportunity to use Zearn and practice your fraction work from the beginning if you don't understand it. But hopefully most of you have a grasp of it, because you need to understand fractions in order to do decimals. My daughter and I have been doing some sculpting with clay, and I finally got to do some sculpture on a small scale with some Bakelite clay. And that's scary. That's called a grotesque statue. Creepy. And we made this cool bowl so I can put stuff in it. A little bowl for the table. Anyway, okay, so what we're looking at here is lesson 1. They are asking you to understand the most basic decimal we have, which is the tenths. We're just going to focus on tenths today. So simple. Very, very simple. And you have this number line and this fraction tape, but it's a little bit different than fraction tape, because we are not going to write any fractions inside this tape here. They're going to be written down here on the bottom. And the directions say to shade the first 4 units of the tape diagram. So let's do that right now. I'm going to shade. Okay, I shaded 4. And we need to recognize now that we are talking about a value between 0 and 1. And in order to get from 0 to 1, how many parts do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the denominator, tenths. And you can see right here, let me zoom in a little bit closer. And focus. Okay, you can see that we're dealing with tenths. All right. Okay, and so what we want you to know, or what we want you to practice, is whenever we say 0.1, that means 1/10. That is 1/10 on that place value chart, that first number after the decimal point. That is tenths. And in this case, the first one here is 1/10. So what is the second one? 0.2 or 2/10. Get used to saying that when you see that decimal, 2/10. The next one, of course, is 0.3, or we say 3/10. The next one is 0.4, or we say 4/10. All right, let's explore the rest of this number line. As you might imagine by now, the rest of it follows pretty easily. Okay, so the next one would be 0.5 or 5/10. The next one is 0.6 or 6/10. The next one is 0.7 or 7/10. The next one is 0.8 or 8/10. And then we have 0.9, that is 9/10. And look, we're at one whole number, of course, that is 10 over 10. So in decimals, when you get to the ones place, or that first number, the one, that one whole, that is 10 over 10. That's 10/10. So 1 is always, the denominator and numerator are the same. But since we're talking about tenths, it's 10 over 10. Now, the rest of the question says, circle the decimal that represents the shaded part. So I'm going to do that right now. And I want you to do that on your problem set. When you do this on Cami, when you turn it in, I hope most of you guys know how to use Cami. I'm not seeing any assignments turned in lately. Maybe 2, 3, or 4 turned them in last week. And Monday, we had 2 people turn in their morning work in math. I'm very disappointed by that. I hope I see more work. I need some work to grade from you guys. And this stuff is so easy. All right, now let's look at the next one. Now we're going to look at the measurement of a liquid in a bottle. And if you remember from talking about the metric system, we use liters, or the L, to represent liters or volume. So the volume of this is in liters, but in between the liters, we're going to say there are 10 parts, or tenths. And then here's your halfway mark here, 0.5 liters. But what is the shaded part? Remember, there are 10 parts here, so the bottom number is 10. And then we count 1, 2, 3, 4, 5, 6, 7. 7/10. And if we look up here at our scale, we know that 7/10 is 0.7. You don't always have to say 0.7, but it helps you understand what decimals are by putting that 0 there. It's a common practice to put the 0 when there's no value in the ones place. And I want you guys to finish that off by yourself. And if you look at the third one, you have to work backwards. It's 3/10, so you have to give us the fraction and then also the shading here. Okay, let's quickly look at the rest of your problem set. If we look at the bottom, we're on a scale and we're using kilograms now. So with kilograms, this one is saying we have some grocery items here, and when you put them on the scale, it weighs 0.7 kilograms, 7/10 of a kilogram. So they want you to put the fraction here, 7/10 of a kilogram. See how easy that is? You want to know that first number is always in tenths after the decimal point. Okay, the next one, I want you to do that on your own. You write the decimal in the scale picture there. Okay, let's move on to the second problem set page. Whoop, that's the first one. Okay, here's the second page of your problem set. That's going to be the second file that you have. It says we're looking very closely at a metric ruler, and I gave y'all a printable that you could use at home to make your own ruler. And you see here that this one is also in centimeters, and look, it's not quite to scale. The magnifying glass makes it look bigger so we can see closer. That in between your centimeters are millimeters, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 millimeters makes 1 centimeter. So it's actually a decimal or a fraction of a centimeter when we're talking about millimeters. But in this problem, they're asking for the decimal and fraction form of centimeters for the length of this ladybug, and you can count 1, 2, 3, 4, 5. To me, it looks like 5/10. So you would put it in fraction form, put it in decimal form, and then it asks, how far does the bug need to walk before its nose is at the 1 centimeter mark? So how far does it have to walk? How much more does it need to get to 1? I think you can figure that out. All right, let's look at number 5. It says, fill in the blank to make the sentence true in both fraction form and decimal form. Okay, so what do you have to add in decimal form on this first column? This is going to be fractions for this column, and this column is looking for the decimal. So they're asking you, how much more do you need to make 1 whole? So basically all you're saying is, at 8/10, how many more tenths do you need to equal 1 whole? 10 over 10. So think about this 1 centimeter as 10 over 10 centimeters. Well, to get from 8 to 10, I just need 2 tenths more for this one. We can reverse that. What do you add to 2 to get to 10? 2 plus what equals 10 over 10? I think you can work that out on your own, but let's look over here at the decimal column. We have 0.8 or 8/10. What decimal do we add to 8/10 to get to 1 whole number? What do we get? What do we need to go from 8 to 10? What do we add to 8? Well, just like over here, we have to add 2/10, but we're going to write it in decimal form. So figure the rest of these out here. And the bottom is pretty easy. You're simply matching the fractions, the decimal, and the word form of the decimal and fraction. So 3/10, they give you the first one. 3/10 is equal to, is represented by 3/10, and it's also 0.3. Let's do another one. What is 5/10? Well, I see 5 over 10 here, so it goes there. And then, where is it over here? It's way down here. I have 0.5 is 5/10. All right, man. This is super, super, super simple. Even a gargoyle can do it. So, guys, do your best. Enjoy your decimals. And on Thursday, we are going to jump up to hundredths. And we're going to get a little bit more complicated, but I think you guys can handle this. This is a simple, easy decimal stuff right now. Focus on the tenths. It's all about the tenths today. Take care. Bye-bye.